Hello everyone. I hope all of you are having a good time. Myself Sudeep Das, and today we'll discuss motion in a straight line, which is the third chapter in class 11 physics. So you can see the syllabus for the session 2020-21 recommended by CBSE on your screen. So firstly, this is a chapter like along with motion in a, now this the present chapter is motion in a straight line. The next chapter is motion in a plane, and then you have Newton's laws. Now all of this comes under the division or the unit called mechanics. Okay, so firstly you need to know what is mechanics. So mechanics is a branch of physics, right? So here you study about forces and motion, all right, and the relationship between them. Okay, now when you talk about mechanics, we have three divisions of mechanics. One division is your statics, the other division is your kinematics, and the third division is dynamics. Okay, so in statics you study about objects at rest. Now examples will be studying the structure or the design of buildings. Okay, design of buildings, bridges, etc. These will be the examples that you study over here. Next you have kinematics. In kinematics you study about objects only, and you don't focus on the cause of motion. You study about the motion of objects. We study about motion of objects only, and we do not go into the reason of motion, which we go into in dynamics, which we look into in dynamics. Okay, so here only the properties of motions are considered in kinematics. In dynamics it deals with cause of motion. It deals with cause of motion. That is what you see in dynamics. So here you study about the effect of forces in causing motion. So you study about effect of the forces in causing motion. All right. So these are the divisions that mechanics is divided into. Next, we have the concept of rest and motion. Now you see, I'll put an example initially, and then we'll get into the definitions of rest and motion, which will enable you to understand clearly. Now, firstly, if I tell you you have three persons, A, B, C. Okay, say A is 80% good in mathematics or skilled in mathematics. B is 60% skilled in mathematics, and C is 40% skilled in mathematics, right? Now you ask A that B and C are good or bad in mathematics. What will be A's response? Obviously A will say that they are bad. Okay, now you ask B that A and C are good or bad in mathematics. B will say that A is good in mathematics but C is poor in mathematics, right? Now if you ask C that A and B are good or bad in mathematics, C will say that A and B are very good in mathematics. Now you see where with respect to what or with respect to whom the comparison is being made here is when you ask A, obviously A will compare with himself and he will make the judgment. When you ask B, he compared with himself and made the judgment, and thereby it goes with C also. Now that is what which happens in real life also. Like you define a situation, you explain a situation, and that is always with respect to your understanding. Okay, you are kept as a frame of reference here. Now this frame of reference thing we'll see in a short while again. Now let's come to the definition. We'll come back to this example again. Rest. What do you call as rest? Now you call something as something at rest if it does not change its position. That means the speed of the body is zero. If it does not change its position with respect to the trees surrounding, with respect to the building surrounding. Okay, with respect to the building surrounding, with respect to a car surrounding. Say the car is also at rest. Okay, so in that case, you'll call the body is at rest. That means with the progress of time, the body does not move. The body does not move with the progress of time. That in that case, you'll call the body to be at rest. So what can be an example for this? A building is at rest, right? Now, when you say a building is at rest, by default you are saying that the building is at rest with respect to the earth. Okay, building is at rest with respect to earth. Because if I ask you, is the building at rest with respect to moon? The answer will be no. So you need to consider, or you need to understand the body with respect to, or the frame with respect to what you are defining the state of rest or a state of motion. Sorry. So next comes is your motion. So how do you define motion? You see, you call a body to be in motion if it changes its position with respect to its surrounding with the progress of time. Now you have a car, and it is moving, all right, in a certain direction. The car is moving in a certain direction. Now the car is changing position. Initially, say the car was at x1, and after time t, the car is at position x2. Okay, the progress of time is t. Now with the change of time, or with the passage of time, the car has changed its position with respect to the surrounding. The surrounding, you say, you have trees, you have buildings, all those are at rest, and the car is changing position. Therefore, you'll call that the car is in motion. So here also you are considering a frame of reference to define the state of rest or motion of the car. What is that frame of reference? The frame of reference could be the earth. Okay, the frame of reference could be the earth. The frame of reference could be buildings. All right, that frame of reference could be trees, because with respect to this, the car is changing its position, or you can say the distance of the car from of course it is happening on the earth, you cannot consider it in that manner, but if you take the building, okay, the distance of the car from the building is changing, the distance of the car from the tree is changing. Therefore, with time it is changing, right? Therefore, you can say that the car is in motion. Okay, so that's how you define rest and motion. All right, now in this universe, there is a statement written over there. You can see. Sorry. Okay, this particular statement. In this universe, there is nothing such as absolute rest or absolute motion. There is nothing such as absolute rest or absolute motion. Rest and motion are always relative terms. Now, what is relative? Relative का मतलब होता है comparative. All right. Now, you say something at rest, you are comparing the body with something else, and you are saying that it is at rest. Now, when you say something is at rest, you are comparing the body with earth in general. Okay. Therefore, the last statement says, unless stated otherwise, when we discuss motion, we mean with respect to the surface of the earth. Okay. So when the frame of reference is not mentioned, in general, you consider that to be the earth frame. All right. So you say some body is at rest, you are saying that the body is at rest with respect to earth. The same body is of course not at rest with respect to moon, with respect to Mars, Jupiter, or sun, or some other galaxy it could be. Okay. So there is nothing which is at absolute rest in this universe. Okay, it could be at rest with respect to something. All right. Similarly, there is nothing such as absolute motion in this universe. Okay, so from here we come to frame of reference. So what is this frame of reference? So frame of reference is a set of coordinates. Now this will be the mathematical definition. It's a set of coordinates that can be used to determine the position and velocities of objects in that particular frame. And the other simple definition is the place from which motion is observed and measured is called frame of reference. Now you see, when we talk of the mathematical definition, this page is coming again and again. So when you are considering the mathematical definition, you are considering a coordinate system, x, y, z, or x, y, z. Now this is a three-dimensional coordinate system. Now if you have a body here at time t1, all right, at time t1 it is here, the position is x1, and at time t2 the body is here, the position is x2. That means with respect to this frame of reference, the body is changing position. So you can measure the speed or you can measure the position of this particular body with respect to this frame of reference. Now this is the frame of reference here. So the second statement tells you, the place from which motion is observed and measured is called frame of reference. Now you see, an accident happens, a collision happens between two vehicles. Okay, a collision happens between two vehicles. And you see this collision from the top of a building, all right, from the top of a 10-story building, right? Now what you will view is the top view. What you will see is the top view of this event happening, all right, of this event happening. Now somebody standing on the street will have a different view. He will have the side view. He cannot see what has happened on the top of the vehicle, right? So you two will be able to explain the same situation, but with slightly different manner, in slightly different manner. Okay, so that is what this is, one frame of reference, and you were standing on the top of a building. You are at a different frame of reference. All right. So in the previous example, if we travel back to the previous example, this ABC thing. Okay. So A was explaining, or A was describing the situation of B and C in doing mathematics with respect to himself. B was describing with respect to himself, and C was describing with respect to himself. Okay. So now we include one more example. I presume that all of you have traveled by train. Okay. Say this is a train. Okay, and you are traveling from Itanagar to Guwahati. Okay. Now A is a person sitting there, C is another person sitting there. All right, and here you have the station, railway station. This is the station, and D is another person sitting there. Of course, D is at rest, and the train is moving, all right, in this direction. So if the train is moving, obviously with respect to D will see that some time ago the train was here. In the present time the train is here. After some time the train will be here. So you can say the distance of the train from D is changing with time. That means obviously if you ask D what is happening with the train, whether the train is at rest or in motion, D will say that the train is in motion, right? Now if you ask D if A and C are in rest or motion, obviously D will say that A and C are also in motion. Now I ask you some questions here. Number one, if C is asked, A is in rest or motion, mind it, both A and C are sitting inside the train. If D is asked, A is in rest or motion. Now what will be the answers? What will be the possible answers? Number one, okay, the most common answers will be, because there is no right and wrong answers in this kind of situations. You'll see number one, if C is asked, C will say A is at rest. Under what conditions he is saying that in that manner? The distance between C and A is not changing with the progress of time. Okay, the position of A is not changing with respect to C. With respect to C himself, A is not changing. A is sitting in his own place. Therefore, C will say A is at rest. Of course, C is saying that with respect to himself. Okay, this doesn't need to be mentioned. By default, it happens always. C will say A is at rest. Number two, D will say A is in motion. Now D will also say with respect to himself. Okay, I hope you got this. Now this is pretty obvious, right? Now two persons are describing the same situation, same event in a different manner. C is saying A is at rest, D is saying A is in motion. Okay, now you look at the frame. In the first answer, the frame was C himself. and the frame is on the train itself. The train is in motion, the frame is also in motion. But when C is explaining the situation of A, she is assuming that C himself is at rest. Okay, so whether you consider the frame to be in motion or at rest determines your answer. Okay, on that thing your answer will be dependent. Now D is also sitting on Earth. The entire Earth is moving, right? But D is ignoring that, and D is thinking that D is at rest because D is sitting on the surface of the Earth, and D is watching this event happening, right? So since D is at rest, because D has considered himself to be at rest, although he is not at rest absolutely, as I said previously. Since the Earth is in motion, D is not at rest. Okay, is not at absolute rest, but D has considered himself to be at rest, and D is saying that he is in motion. D is also correct. Now these answers will be more precise if you say in this manner. If you say, now I'll give the responses of C and D in both ways. C will say A is at rest with respect to the train or with respect to C himself. Okay, that could be one of the answers of C. When C wants to insist on, or when C wants to emphasize on rest. Now C can also say, this is response number 1, possible response number 1. Possible response number 2, C will say A is in motion. A is in motion. Okay, with respect to the Earth or with respect to the railway track. Okay, or with respect to a tree passing by. With respect to a tree. Okay, in fact the tree doesn't pass by, but you pass by. So with respect to a tree surrounding or at a certain distance that you can see through the window. Okay, so or with respect to a building even. So this could be the possible answers. Now if C wants to emphasize on motion, this could be the possible answers. Number 2. Now what will D say? D will say A is in motion with respect to Earth or with respect to D, right? So if D wants to emphasize on motion, this will be the possible answer. Number B. D will say A is at rest. Okay, with respect to C or with respect to the train. So this could be the possible answers of D. I hope these are clear. You do not need to make any notes of this. These are just for understanding. So if D wants to emphasize on rest, then D will give these possible answers. All right. So this can be the possible situations or the possible answers from this particular event. Okay. I hope this is clear. Now one more question, an interesting frame of reference question was discussed. It is very interesting. Albert Einstein, he is known for the theory of relativity, right? So there is a question: why did the cat cross the road? Now Einstein was asked. You asked this question to Einstein. What would be his answer? What was Einstein's answer based on relative motion and the concept of frame of reference? Look, Einstein would say it totally depends on the frame of reference of the observer, whether the cat crosses the road or the road crosses the cat. Now you see, I'll go back to the previous situation once again, so to explain this answer. Now here, you consider A as the cat. Let me copy this entire thing there. That will be convenient for understanding. And let me remove this section. Now here, consider A as the cat. Now C is one observer, D is another observer. Okay, or in other words, C is one frame of reference, D is another frame of reference. Now, if the observer C is crossing the road with the cat, right, then C would say A is at rest. Yes, because C is also in motion with the same speed in the same direction, right? So if C considers himself to be at rest, he will say that A is at rest because the distance between C and A is not changing. Now, of course, they are crossing the road. Okay, the final result is what? You see, some time back, you see C, or you see this, A and C on one side of the road. Sometime later, you see them on the other side of the road. Okay, so definitely some motion has happened. The motion, two possible motions could be there. The two possible motions could be either they have crossed the road. Under that situation, you will find both of them on the other side of the road. Or the other situation can be either the road has moved backwards. In that situation also, they will be on the other side of the road. I know this is pretty baffling to conceive, okay? But if you look at more examples, like when you walk along a street, okay, and you are crossing the road, say. Now, two situations can lead you to the other side of the road. You stand there and the road moves backward. You will be on the other side of the road. Or you walk across the road. In that situation, the road is at rest. The road stands there, you go to the other side of the road. In that situation also, you are on the other side of the road. So you can look into this example once again. Either the road will move backward or you will move forward. Okay, either of these two situations will happen. Okay, I hope this example is clear. Now, if you consider this cat as A and observer C, the observer which is also in motion with the same speed and direction as A, okay, and like the previous example, this was the train. C was considering himself to be at rest. C said that A is at rest, right? So just like that, both of them are crossing. Now this train situation is not there. Both of them are crossing the road. Now C is considering himself to be at rest. So C is saying that he is at rest, right? In that situation, the road is crossing them. So in the previous situation also, if I tell you the train situation, when C said that A is at rest, right? Because they were inside a train and the train was moving in a certain direction. When you ask C about a tree standing outside, now if C says that A is at rest, and if C says that C himself is at rest, then they will say that the tree is moving backward. Yes. If the tree can move backward, why not the road can move backward? Okay, try to think about it. In case you have any questions, you can ask me through DM, through comments. Now, the situation with D is pretty obvious. That is something we have been thinking in this manner right from our childhood, that D is at rest and D will watch the event, that A and C, or just A, if the question is about A, the cat is crossing the road, the D will clearly say that the cat is crossing the road. No complications with that, but regarding the other way of thinking, you might find it a bit different. But think about it. This is how you think in respect of frame of reference. Okay, so these are the notes of the chapter. I'll share the same notes through WhatsApp groups. Okay, regarding the remaining discussions, the types of motions and all, we'll include that in the next lecture. Thank you.